Start recording.
Yeah, we can start recording. So welcome everybody to this new seminar of NetPlace. Today we have Jan Schulz and Daniel Meyerhofer from the University of Bamberg in Germany. They will talk about a network-based explanation of perceptions of inequality and privilege, which seems, as I said before, very interdisciplinary. So I hope the discussion will be very interesting as well, because it touches everybody of us. So yeah, I don't know how you will manage starting first, but I'll give you the floor. You if you need anything, just you can ask.
Yeah, we'll figure it out, I guess. Okay.
Yeah.
Okay. So thank you very much for the kind introduction, and hi everyone. Today we're going to talk about two interrelated projects on perceptions of inequality networks, one on overall inequality and one on more gender-based inequality. And this is a joint project together with Daniel, who is also here with us today, and actually also with our student assistant, Carsten, who is, I think, also joined in this call. So hi, Carsten. And this first paper is also co-authored by Anna Gebhardt from the Institute for Mathematical Optimization, also in Germany at the University of Magdeburg. Okay, so why did we start this project? What was the basic motivation? So these two guys are perhaps the most prominent politicians today in Germany. Friedrich Merz is the opposition leader, and Olaf Scholz is, of course, chancellor. And they both, even though they're probably in the top decile or even percentile of the German income distribution, they both somehow felt the need at some time to claim they're in the middle class, which is, of course, a bit strange. And we were interested in why they felt the need, why this is a strategic necessity for them to claim that they're in this middle class. And the reason for this, I guess, is that pretty much everybody feels that way. So they appeal to a large majority of the German population. So here you see the frequency density of self-assessed income deciles in the German income distribution for several years. And for correct self-assessment and for a representative sample, you would expect that there is an approximately horizontal line here at 10%, since, of course, every decile consists per definition of 10% of the population. However, you have this striking peak here at the middle categories. So basically everybody in Germany thinks they're somehow middle class, even though this is objectively and demonstrably untrue. And this is no outlier. So Germany is no outlier here. This is a very persistent and robust phenomenon, basically for all the states. This International Social Survey program is conducted, and in the literature, this is coined a middle class bias. And this is, of course, intriguing and led us to the formulation of our model. And so this is one of our 4 stylized facts by which we want to validate our agent-based model we want to present you. The first is that irrespective of the objective status, all people think they're somehow middle class. And as an immediate corollary to this, poor individuals think they're richer than they actually are, and richer individuals think they're poor. In terms of perceptions of more societal inequality, poor individuals tend to perceive inequality to be on average higher and are closer to the objective or true state of things. And finally, the 4th stylized fact, and maybe the most problematic one, is that perceptions of inequality do not seem to change much if objective inequality changes. So if inequality goes higher, this goes mostly unnoticed in the general population. And we want to explain this within a network framework. And as you all are perfectly aware, a specific kind of network that Daniel is introducing to you in a second, that builds on two major properties of empirical social networks, namely homophily and the small world character of these empirical social networks. And this is the basis of our model that Daniel will now introduce to you.
We developed a special kind of random geometric graph type model to represent the empirically observed homophily that Jan was talking about. So people forming links with those others who have a similar income as themselves to kind of represent the closest layer of personal interaction. And in our network model, we have each agent, so each node draw 5 linked neighbors with weights for this draw being exponentially inversely related to the distance in income between drawer and potential drawee. And the strength of the relation now depends on the homophily weight rho, with rho being 0, meaning a random network. So their income distance doesn't play a role at all. And for rising rho, agents with great income distances become very unlikely very quickly due to the, exponential nature of the weight. Now, given the homophilic network, individuals estimate inequality and also their own position in the income distribution, their own income rank, by simply assessing their personal network, meaning they do all pairwise comparisons in that network for Gini estimation and obviously place themselves in relation to their linked neighbors. And hence they simply do standard calculations of these measures without any bias, but, but based on a locally limited knowledge imposed by their ego network. As for the income distribution that we feed into the homophily process, we generally work with exponential distributions with a Gini of 0.5. This is in line with empirical data for at least the industrialized countries. And then we also introduce log normal distributions because we also want to understand the relationship between actual inequality and perceived inequality. And to that end, we obviously can't work with the exponential and use log normals instead. Now, the main emergent mechanism from that homophily and the distributions is that people tend to find themselves having the median income in their own personal network, and we can also prove this analytically. The only exception are agents at both ends of the income distribution, and the affected ranks quickly shrink with rising homophily. So this is the main driver of our results. With regard to network properties, we find weak small worldiness, i.e. we have only slightly longer average path length than for a random network, but way, way stronger clustering. And this clustering, next slide, please, Jan. And this clustering also becomes apparent when looking at the frequencies of links within one's own income design. These frequencies would, of course, be 0.1 if there was no clustering. But as you can see, they are way higher in our model, especially for the income rich, the right part of the graph here. What you can see here holds for all levels of homophily, and the effect obviously becomes stronger with rising homophily. So homophily causes a high level of segregation, especially for those with high incomes, who have a majority of linked neighbors, as you can see, within their income design. Everyone tends to stick with their like, but the income rich do so most extremely.
So going from these topological results back to perceived inequality, we indeed can generate this first stylized fact that almost everybody appears to be or feel or perceive themselves to be in the middle class. For a rather low homophily strength, this tendency is not as apparent, but if you increase rho to 8 or 14 in this case, you see empirical densities that are strikingly similar to the ones I just showed you a second ago. So we can indeed replicate this first stylized fact without any additional assumptions. And of course, by extension, we also find that the rich tend to underestimate their own position and the poor tend to overestimate it. So we can also directly generate the second stylized fact. Regarding inequality perceptions, so perceptions of overall inequality, we also find that we can generate some of the behavior that is in line with stylized fact 3, that the rich tend to underestimate over inequality the most. So here you have the income rank going from the poorest to the richest, and on the vertical axis you have the perceived Gini in each ego network. And as you can see, this perceived Gini decays at least linearly, or here superlinearly, in income rank. And the reason for this is that I'm not sure if you're all aware of how the Gini is calculated, but you have essentially the sum of all income differences within the ego network, and the denominator is the mean income within the ego network. And these sum of income differences grows at most linearly, while this denominator increases much faster exponentially, leading to this strong decay. So indeed, we can replicate also the stylized fact 3, that the rich tend to underestimate overall inequality the most. And finally, regarding changes in actual inequality, we can also replicate the stylized fact 4. So remember that the stylized fact was that people tend to not perceive changes in actual inequality as such. And here we plot the actual Gini coefficient on the horizontal axis and the mean perceived Gini on the vertical axis. And we do this, as Dani told you, by taking a log normal income distribution and varying the dispersion parameter sigma to generate different kinds of inequality levels. And apart from this very unrealistically low degree of inequality, we indeed find that increases in actual inequality translate not one-to-one into mean perceived inequality. So here, for example, changes in actual inequality do not seem to affect inequality perceptions at all. And the reason for this is that we have two counteracting effects here. First, if you hold the network constant, increases in actual inequality, of course, also translate to increases in inequality within the ego network. However, we also reshuffle the network, so the higher the inequality is, the higher also the segregation tendency becomes, and the more selective I become in choosing my linked neighbors, which then decreases the inequality perception. And these two effects together seem to almost offset each other, explaining this plateau of inequality perceptions and the fact that increases in inequality do not seem to be perceptible in our model. Okay, so this was shortly the first paper. Are there already any questions on this before we move to the second paper? Anything unclear?
I have a question.
Yes.
I didn't understand properly how the network is constructed. I mean, the topology of the network, which are the nodes and which are how the links are made. And also, when you say segregation, you mean Schelling-like segregation, for understand like something that is related also to the position of the nodes, or only a strong homophily or clustering? By the way, nice work.
I'll start with the first question maybe. So what's probably the easiest notion of grasping what we're doing is we're basically applying some kind of mechanism that is similar to preferential attachment, but we apply it to a feature that is not a degree. Okay, so we have these weights in the preferential attachment that correspond to degree, and instead of the degree, we have this income difference. So if we have obviously an exponential version, so we can't do it linearly, but if it would be linearly, if your income distance was twice that much away from mine, or if your income was twice as much away from mine as Jan's, I would be twice as likely to choose Jan. And because we're doing exponentially, it wouldn't be twice as much, but that's the idea. And then the linkage formation is really basically what we know from preferential attachment. So it's actually quite intuitive, more intuitive than what the classical random geometric graphs do. And as for your second question, what we're meaning here by segregation is really just how well does the network, or how well do the individual networks represent the plurality in the overall income distribution. So it's not a feature of the network, but it's the relation between network and distribution. Does this make sense? Yeah. Okay. And as you mentioned Schelling, I'll also take the opportunity to say that the idea of having homophily in income, it doesn't really imply that we believe that people actually pick their personal contacts because they want others to have, or they want to interact with others who have similar income than themselves, but they do so because, well, we all know others who have a similar income than ourselves. Our colleagues tend to have a similar income than ourselves. The people that live in our neighborhood, and that's probably the link to the Schelling idea, right? They have a similar income than ourselves. So there is this income homophily as a byproduct of, well, the homophily that our everyday actions amount to, essentially.
And yeah, maybe as an additional comment, so you can also analytically derive the probability of each node rank to choose another node as a linked neighbor, essentially. And so this is what we mean by segregation. So here, this richest guy basically only wants to stick with guys like him or her, and nobody else. And for these lower rank nodes, they are much less selective, and therefore we would say that they have a much lower segregationist tendency.
Okay, thanks.
You're welcome. Any more questions on this?
I also have a question, actually. The figure before, where you showed that the thing, there were like this, the figure of 2. Can you like, there was the one that was like 10 small cups.
Yeah.
This. Can you say it again? What you're doing here? What do you mean by how this come up?
So we're essentially plotting how many of the linked neighbors of each agent, so each blue dot would be one node, and we're plotting the proportion of linked neighbors that are in the same income decile as this node. So if I'm, say, in the lowest decile and all of my linked neighbors would be in my decile, the value would be 1, right? And obviously what we would be theoretically be expecting would be 0.1. If there was, not theoretically, if there was a complete random network. And we have this cup form because obviously the ones that are like at the at the edge of their decile, they're more likely to pick others from the neighboring decile.
Okay. And there is a specific reason why you're doing this with each decile? Like you're checking in each decile. Why is the reason behind this?
The most empirical studies that are done on this are based on deciles, because if you have a sample size of 1,000, then deciles are kind of the lowest you can go in granularity.
Makes sense. Okay, thank you.
It's actually a good idea. We could consider also plotting the relative distance in income for the ranks. Yeah, thanks.
Any more questions? Okay, so it does not appear to be the case. Then we can move to the second, much shorter paper. So don't have to bear with us too much longer. So this is essentially a paper on perceptions of the gender wage gap. And as you're all aware, sadly, the gender wage gap persists in all industrialized countries. You have, just to give you a range, I think in Bulgaria, it is the lowest wage gap of 2.6%. In South Korea, you have over 30%. So this is the empirical range of wage gaps, which is the percentage difference in median incomes for men and women in these countries. And this topic of gender wage gaps is well understood, I think, and there's much empirical work done in economics, but perceptions of the wage gap are somewhat understudied, we think. And this surprised us, and this is where we also try to extend our model to this issue. So again, there are two stylized facts on gender and racial wage gaps. First, we again have that all people tend to underestimate the actual extent of wage inequality between these groups, but the underprivileged tend to have a higher and more accurate perception of this corresponding wage gap. So women are closer to objective reality, and also ethnic minorities are closer to objective reality than the respective privileged groups. And we also know where these perceptions are formed. The first channel is global information, for example, through national media, that is simply reporting a figure for the gender wage gap, or activists notifying us, for example, through the Equal Pay Day and stuff like that. So this is the first source of information, and the other source is the lived experience of people, especially in their workplace, where they essentially extrapolate from their experience and try to form their perceptions of the wage gap from this kind of situation. And they somehow combine these two signals, and this is what Daniel will again now show.
Yeah, as Jan said, we model an agent, an individualized perception of the wage gap as consisting of a local and a global component with, as you can see here, individual relative weights. Also, as Jan said, the wage gap, the global society-wide wage gap is actually easy to determine. And this global wage gap, easy to determine, and also quite intuitive to communicate. And this actual true wage gap, true society-wide wage gap, forms the global component and is identical for all agents. Now, contrary to that, the local component varies between individuals. So in the rare occasion where an individual has no linked neighbors outside their own privileged group, so say privileged agents have only privileged linked neighbors or vice versa, their local estimate would be 0. Otherwise, the individuals compare the mean incomes of their privileged and their underprivileged neighbors, and of course, including themselves in the respective group, and then they normalize the resulting value. In other words, agents have no innate bias when perceiving the wage gap locally, but carry out a standard wage gap calculation. So standard calculation as we've seen for the general inequality case. So very much the same that government statisticians or research agencies, researchers do. So however, the individuals base their calculations on locally limited information that stems from their ego network again. Now this network is formed as we've seen before. So linkage is only based on income. So we do not include any homophily in group, but only homophily in income. And as input for that, we use, again, an exponential income distribution for both classes. But for the underprivileged, we retrench the incomes by the wage gap G. And this again is consistent with what we see empirically. And so this picture that you see on the bottom actually depicts what happens. So we have homophily in income, in this case, two anecdotal groups, one with money, the others without. And accidentally, or kind of accidentally, this also happens to bring homophily in the group, even though there's been no explicit privileged group homophily.
Yeah, so if we simulate this model, so this is just the local perceptions within each network at the moment. We get these results for different wage gaps, 10%, 20%, until 40%. And essentially here you have the homophily strands from 1 to 14, which is the empirically relevant range according to our calibration. And this is always in relative terms. So 1 would be the correct perception, and 0 would be basically we don't see any wage gap here. And this is again decomposed between the perception of the underprivileged and the privileged. And what we see here is, increasing homophily quickly leads to a reduction in the perception of gender-based inequities. So this is in line with the empirical results. However, just as a reminder, the second stylized facts also required us that the underprivileged are closer to the objective reality than the privileged. And this is what we don't see here. So essentially the privileged are all, the privileged violent plot is almost always higher than the privileged, the underprivileged violent plot is higher than the underprivileged violent plot for reasonable degrees of underestimation. And only if you go there for really high degrees of homophily, then the picture changes. However, then people don't appear to observe any kind of gender-based inequity. So these local perceptions first seem to be quantitatively too strong to account for the empirically observed phenomena, and also they don't appear to be in line with the second stylized fact that the privileged tend to underestimate these inequities more strongly. So these blue violent plots are closer to the 0 line than the orange ones. And this is essentially the reason why we need to consider this composite rule, where where agents combine the correct global signal and this biased local signal. And here we calibrated our results with recent data from Israel on perceptions of the gender wage gap, and worked out the weight each individual group puts on this global signal according to different degrees of homophily. And as you can see, for both groups, they appear to place a significant weight on this global signal. So they're not only basing their perceptions on their local networks, but also what is objectively the case. But the underprivileged always have a much higher weight for the global signal than the privileged. So the underprivileged appear to listen to the correct global information much more closely than the privileged do, which is maybe in line with our intuition about this, since of course people adversely affected about discrimination might also be more interested in information about the issue. This is at least the interpretation this calibration would suggest. Okay, so I guess now Daniel can summarize.
Yeah, so the contribution of both papers are kind of twofold. Methodologically, as I've also explained in the intermediate Q&A, our algorithm basically has a preferential attachment type of notion, but creates random geometric graph type of networks. And this is helpful because it's really intuitive to understand for practitioners. So all the social science people that I know, they have a kind of hard time of grasping the idea of random geometric graphs. And it's easier for them to understand and to mentally work with ideas of, okay, how likely is an individual or a node to form a link with another node? And that's what we can do. And we can also obviously specify a minimum degree. And that's something that random geometric graphs, up to our knowledge, are not able to. We can generate weak small worldliness with the model. And obviously, at the same time, we can kind of apply all the methods that are out there for RGGs. And obviously, we have just worked with income, but you can apply this procedure to any feature of nodes. Once the network is there, an obvious further step would be to add explicit interaction in the network. So we have some kind of knowledge acquisition that sits there, but that's essentially just reading information, face value information about the linked neighbors. But there would obviously be other ways of interaction that could happen. Rumor spreading, working with different sources, all that could go into, or could happen into in our network. Materially, with regard to our application case, we show that individual information sets, local information sets, are important in inequality perception. So we do have a bias across the population, and this bias, that means underestimation of general inequality and of the wage gap, can be a result of homophilic link formation alone. So there doesn't have to be a bias in information processing, but just the locally limited information set. And as we see, we can replicate the empirical findings regarding general inequality only by local perception, but for the wage gaps, we need also to factor in the global signals. And this could testify to the idea that obviously wage gaps are way easier to understand, way easier to communicate to a general public than the rather fuzzy concept of the Gini, of general inequality. Obviously, there are implications. The first one is political, saying that the underprivileged or poorer individuals, they estimate inequality or the wage gap as higher than it actually is, not because they're biased or they're pursuing an agenda, but they're just epistemically in a better position because they have a relatively greater likeliness to see far away income ranks. We can understand how policymaking, how the public discourse happens in regard to inequality, and especially contrast to the wage gap. So why is there greater awareness of the wage gap? Still not enough probably, but greater than for general inequality. And we also see that information treatments telling people about the global values may actually help. As for possible extensions of the model, we have currently under review a model of consumption based on the same homophilic linkage procedure, where we can use our idea as micro-foundations for theories of relative consumption, of consumption cascades, and we see the empirical heterogeneity in consumption patterns as also emerging from our model, interestingly. And this avoids what happens typically in economics, that one has to assume that people make their consumption decisions about their expectations about future income, but they just try to catch up with their linked neighbors' consumption, essentially. Inequality is obviously related to voting, so that would go towards political science, and we're in the early stages of building a model on that. And finally, we generate quite some empirically testable predictions, so that would work well with empirical investigations into social network formation, but also into opinion dynamics. So much for the content-related findings that we draw, or that we can draw from our projects. And now about our personal experiences. So first, how did we do that technically? How did our cooperation work? Which software did we choose and when? The first issue was that we haven't had enough precision in floating point arithmetics for some of our application cases, because the incomes vary that much. And then if we have like the income differences, if we have to treat them exponentially, the values get too high, or rather too low. So we had to work with differential arithmetics, which kind of put some computational constraints on our work, obviously. And initially we had a setup where we built the model in NetLogo, because for maybe some of you know NetLogo, the advantage of this is probably that you can develop stuff basically on the fly, and it's really close to intuition. And then we did just a simulation there, and I sent the data to Jan for analysis and visualization in Mathematica. Currently, we're switching to a more integrated design, where we're using Julia for the modeling, the simulation, and also a preliminary analysis. And then Mathematica basically does the details, does the polishing, because the mathematical graphs, I think they're really neat, and I'm not the one producing them. So yeah, that's our current setup. And we were kind of nudged towards that setup by features about communication with each other. So there was a point where we essentially divided by 2 twice. So I did it, thought, oh, Jan wouldn't have to do it, and Jan thought, oh, Daniel hasn't done it, and he did it. So we ended up with estimates that were exactly half of what they should have been. And we had to correct them later on. So these are issues that happen if you have got multiple people working with different software. On the go, we kind of made sure to sharpen our understanding of all the concepts that we were working with, especially coming from different disciplines, which brings me to the interdisciplinary questions. So we really had to make sure that we're on the same page everywhere. except for our internal communication, there are obviously also external factors. So what were our experience with dealing with multiple sub-projects, right, especially early in the career. So we do need efficient resource allocations, or our own time, obviously. So what Jan and I are doing, it's basically, or these projects are essentially what we're doing in our free time. We both get paid for different projects, for teaching load, research stuff. And then obviously we have Karsten who assists us. Thanks again, especially regarding or given our limited financial means. So we did acquire a small university internal grant, project grant, but getting financing is obviously really hard, as we probably all have known. So I think for us, it seemed really important to focus on funding acquisition early on, also with regard to polishing one CV probably. Given that one is probably in an interdisciplinary project, this may mean that there's not that much experience out there from supervisors. So I think we have both really supportive supervisors. So they're by no means hindering our work. They're supporting us organizationally, but also with their knowledge, but they're probably not as much of experts as, you know, supervisors typically tend to be, because they're simply working on other stuff. And then for career planning, we were explicitly told to by the career service to make sure we sharpen our own profiles. So to make sure that the project, helps everyone individually. This means we have to make sure to meet kind of both our requirements on where to publish, where to present, what to publish, how to sell stuff. And obviously, we need to make sure that, or one needs to make sure that, the allocation of recognition, the allocation of authorship order is somehow fair. So I think it works quite well between Jan and me, because we're kind of always telling the other that they should first author papers. So we've come to the point that we say, we just toss a coin. But this is something that probably should be sorted out early on. And we're also now strategically saying, okay, I'm the one who should first author papers that are more in a political science, sociology context, and Jan is the first author for the more economics related papers. So we both will hopefully further our own career, essentially. And that's it. What we've learned so far from this, still ongoing project. And if you want to know more about it, obviously just do scan the QR code to get to our project website. And now we're keen on your remarks and questions.
Thank you very much. I guess we can stop now the recording while we continue. Maybe also you can share the link here and / Slack, so that everybody can take that from there, because it's very interesting. So let's see if someone has a question. Aline?
No. I mean, should I stop recording for now or after the question session?
As you wish. I don't know. I would say now, but.
Okay.